Hey, what's going on, folks? It's Mike here, and today is an exciting one. Today, in our first impression series, in which I look at a programming language that I haven't previously looked at, installed, or written any significant program in, we're going to be looking at the Rust programming language. I bet you've been looking forward to this one because this is probably the language that people have asked me to take a look at the most and say, why don't you use Rust or so on? Well, my simple answer is I haven't used it. So let's fix that. Let's go ahead and dive in here. So first and foremost, here's the Rust language website here. Now, I do know some things about the Rust programming language just from talking with other people. I've had folks working with me who have been using the Rust programming language, for instance. So Rust itself is probably one of the most popular languages right now. It's a systems programming language, and it's for performance, reliability, productivity. And famously, it's been incorporated in a lot of places where the C programming language has been, or C++ as well, because Rust is considered a memory safe language. So let's go ahead and just explore a little bit of this, and then we'll go ahead and download Rust and learn a little bit of Rust here. And we'll just play around with this for a little bit. So let's see. As Rust is structured, it's a performance language. There's no runtime. There's no built-in garbage collector. And it's been known to run on embedded devices. Okay, cool. So again, it's fitting that sort of niche where the C programming language is. Rust's rich type system and ownership model guarantee memory safety and thread safety. So this is the big thing with Rust. And you might catch me talking about this a little bit on my channel in the D programming language, because D allows you to do a lot of things at compile time. C++ lets you do some things at compile time, and C23 as well will get const expr. And that's probably the best place where you can catch a bug, at compile time. So Rust pushes that a little bit further from what I understand with its ownership model here. And hopefully we'll get into that or see a little bit of what that looks like. In fact, I won't end the video until we at least see some example, because it feels like the main feature of the language, or one of the main features, I should say. So that's one of the things here. The Rust ecosystem, as I understand it, has their cargo tool, which I know a little bit about, and basically makes it easy to package things up and just get things to run on multiple platforms. So that's a big win for the programming language. We've started to see this if you've been watching the other videos that I've done here, like with Go. Makes it really simple to just do Go run. VLang was sort of the same way, or V, excuse me, that's called. So anyways, let's go ahead and see here. Oh yeah, and there's some other cool stuff here, like we can target WebAssembly. So that's really cool if we can write our programs in Rust and then deploy them to the web. That's super powerful. I like having just one code base as well, rather than separate implementations of things here. Okay, yeah, building tools. And this is where I've seen Rust, and other languages too. This was true of D, where I see it sort of start sneaking into companies where folks just start building their own little command line utilities. But Rust, as I understand, is seriously being used in major tech companies, large and small, which is kind of neat to hear about. Okay, so some networking stuff, and of course embedded, because it's kind of living in that C space here. Okay, so let's go ahead and get started here. I think we're going to go through part of the Rust book here. It looks like there are some Rust conference videos, so lots of great resources. Again, this language, as I understand it too, is backed by Mozilla, so that's been like one of the big things. With language adoption, sometimes having a large sort of corporate sponsor can be useful. I don't know exactly their model. That's something folks can come in the comments, and feel free to correct anything in the comments. I won't mind. I mean, you folks will be the Rust experts probably if you're commenting. Okay, let's go ahead and see Rust up. Okay, primary way that folks install Rust is through this tool here, which is Rust installer and version management tool. Okay, if I'm on Mac, Linux, or Windows here, I'm assuming I can just type this into a terminal and it'll run this script here. So curl is a great tool for downloading things, and yeah, it's just going to install this shell script. Are we going to trust it? I guess so. We don't have a choice. Let's go ahead and paste this in here and see what happens here. It's going to download our Rust up installer. Let's see here. Oh, looks like I have an existing installation here. Okay. Yeah, I did try to run something once here. Let's go ahead and say proceed with installation here. Okay, so that's cool. Again, I like these tools that, are smart but lightweight when it comes to installing things. Okay, cargo's the build tool. Okay, and we get that for free. Great. Yeah, I don't want to install multiple things. And then there's other tools like text editors. We're just going to use Vim probably. Okay, then we got some other stuff on. Yeah, we'll go through this little bit here and write our little hello world here. All right, let's let this download though, and while that's downloading, we'll get this set up here. All right, so let's just go ahead and split the window here, make it a little bit bigger here so that folks can see, and then let's go ahead and generate a new project. So first, let's see if I just type in Rust, or is it just RS here? Okay, well, we'll figure that out here. Let's just follow the tutorial. Or cargo. Do I have that? I do. Okay. And usually like cargo version or something. Okay, cool. So pretty standard command line stuff here. Okay, let's run our hello world here. Okay, let's write a small application here to start. Cargo. And let's do new hello-rust. Let's see. Okay, so that created, I'm assuming, this folder here, hello Rust. Okay, and we'll run tree here like they've done here. Okay, cool. So we get this source file, and let's see what's in that cargo like configuration file. Okay, pretty neat. It tells us what edition we're using, or version, I guess. Any packages and dependencies. Again, dub for D is similar. Golang has its own thing. So that's cool here. Okay, so we got this manifest file. I like that there's official tools with the languages too. These package managers, you know, this is where C++ has gotten in a little bit of trouble, right? You have like CMake and Conan and some of those different tools, but it creates fragmentation. So, you know, just having the official thing is great here. And this is simple enough here. Just cargo run. Cool. And we'll see if we can just run this with our cargo. I wonder how tightly integrated it is. I always like to know what's going on here, but again, if cargo just works and that makes it easy for everyone to run, again, that's probably the right thing to do here. Okay, so let's add a dependency. Cool, yeah, we want to add some library here. Ferris says. Ferris, I think, is the crab name, right? The logo for Rust, for Rustation, or is a crab. Let's see here. Okay, so let's see. We're gonna add this. I wonder if we add this manually here. Okay. Let's go ahead and do that to the cargo file here. Okay, interesting. Ferris says equals 0.3.1. I wonder if that's how you do it. I'm sure there's like a cargo add or something. Cargo add. Let's see if I had done that here. Ferris says. Let's see what that did here. I'm kind of messing around here. Part of these videos, if you've been watching, I also mess around a little bit. Okay, I don't know if that changed anything here, but now we should be able to do cargo build. I'm assuming it's going to download something. Yeah, crate. Okay, so we have these Rust crates here. And then I guess any of its dependencies as well that it needs here. Okay, a small vector class. Interesting. And then, okay, let's add in our source file here. We need to use... okay. To use this dependency, you can open their main, remove everything that's in there. Oh, interesting. Even the main. I'm going to leave it in here. Use Ferris says say. Okay. Let's do hello Rust. Cargo build. Okay. This crate here. Ah, okay. I can't just put this inline in the function here. Oops. I don't know what I've done here. Undo. There we go. Okay. And do tabs matter? Let's see. Or spaces in this language? I don't think they do. Cargo build. Okay, so it is finding it, but it's giving me some error here, but I gotta just copy it, what's going on here. Okay. Small Rust application here for the previous step. Okay, I added that in. And then I'm gonna use, well, let's see here. What, maybe I broke something here. Cargo build. Cargo run. Okay, so hello world. And then I want to use Ferris : say. Okay. Cargo build. Unused import. Oh, okay. Okay, cool. I was worried I was getting like some sort of syntax here. Let's actually read the error messages. This is something that I think Rust is known for. That's good. Unused import. Okay, so brilliant. I was actually a little bit... again, this is great that it's catching at compile time, because I was a little bit worried. I like to actually start putting for languages that allow it, like D and stuff, where you can put the import in a function. Because then when I'm refactoring and moving stuff around, it's sort of contained within that scope, right? If you're only using it in that function, rather than having it at the global scope. So this is just telling me, hey, this is unused. So I really like that. Keeps your projects fresh. Like, you can have applications sometimes in programming languages where you just have tons of these imports at the top, and it's like, are we even using this? And it's just like messy, right? You're linking in code that may or may not be used, or you're leaving it up to some other tool to determine that. So this is cool here. It looks like it's giving me just a warning for that, rather than an error, but I want that. I want warnings on too. Okay, so let's actually use this thing here. So I'm going to leave the little hello world here. Okay, let stood out equals stood out. Let message equal string from hello from me. I'm going to modify this a little bit so it fits on our screen. And let width equal message chars count. Okay, so that's whatever this is. This many characters. Okay, it's going to count it here. And let mutable. Okay, so something's going to change here. A writer that it's got here. New. And I kind of saw this a little bit in like Go. I think had some sort of writer a class here. Okay, and then say is from this Ferris says things. Our message. The width of our message here. Okay, because it's going to do something with the tabs. And then I guess this is like our output here where we're writing out to. This is a nice pattern, actually. If you're writing functions with like in C++, cout or dlang, write line, or Java, print line, or whatever, it's kind of nice to have functions with output parameters for where you're writing text out to. And the reason for that, rather than just dumping everything out to standard out, is one, if you're just writing everything out to buffers, it's a little bit easier to capture. So I sort of like that pattern. I'm liking that pattern more. Of course, if you're watching my videos, I'm probably doing write line because they're tiny little examples, but I sort of like this. Now, unwrap, I have no idea what that's doing, but we gotta figure it out here. So let's build it. Okay, I don't have buff writer, so I gotta use it. Use from standard input output. Oh, okay, this curly brace. That's kind of a clean way to collect these. Again, some languages will just say like use standard IO dot, or in this case colon stood out. That's fine. Okay, so let's build it. Aha. And let's run. Oh, cargo. I keep doing cargon. And here we go. All right. All right. Thank you, Ferris. Hello from me. So that's cool. Yeah, very nice. I'm liking this. I'm liking this little experience here, but let's learn more here. Let's get into some of the nitty-gritty stuff. I've heard the Rust book is nice. Let's see here. Let's see what Rust slings are, though. Let's make this a little bit bigger. Okay, cool. We got our standard library. Again, any language, any modern language I'm going to use needs to have like a good standard library. Let's just poke around here. The standard modules here. I know there's a lot of Rust crates for things too, but I want like a good standard library. Okay, so you got your containers. Yeah, like a vector library. That's good. That resizes. Okay, here's our primitive types here. This is similar to V, which we're looking at, which just has the types here. I like this with the explicit number of bits. Also, when I'm teaching this kind of stuff, it naturally begs the question, well, what's the 8 mean? And then I can actually talk about this like system thing. So one, it's obvious when you're using it in code what the bit width is, and that's important for embedded devices, if you're writing code on different platforms. And two, just from a teaching perspective, you learn this stuff like right away here, like what the type is. So I like this sort of naming convention. It's a little bit weird. Maybe it's harder to type, but IDEs can probably help with that stuff. Let's see, we've got a char. Ooh, this never. Okay, the exclamation type, also called never. Okay, we'll have to figure out what that is here. Fixed size arrays. Function pointers. FN. Okay. In dlang, we just write this out as function. That's fine. And slices. Cool. Yeah. Pretty much every modern language has some sort of slice these days for arrays. Kind of nice to work with. And this is a view. Okay. So this is like in C++, you have your string view or your spans, which are views into containers. They've got tuple. Okay, tons of modules here. Cool synchronization stuff. All right, so there's a lot of stuff I like here, and that's going to be neat to look at in our standard library. Let's see, what are these rustlings here? All right, for the first time learner, we probably want the book or Rust by example. Oh, what is this? Okay, so we might want to take a look at this here. We want to find like the most interesting stuff to look at here, but it's cool that there is a lot of resources here. Okay, so get a bunch of this stuff here. So let's read. Let me see. Is this the Rustlings course? Okay, yeah, I think so. I think we've got this here, and then we've got read the book, which is cool here. Having an official book that's like up to date and free. Again, good thing for language adoption. The Rust folks, really did a lot of nice things here. There's a reason the language got popular and has been loved by many. I've seen various surveys. Okay, so we kind of did some of this stuff here. Let's program the guessing game. I think that's a cool way to start programming. I actually teach this as assignment in many of my classes, right? Classic game, we're going to have the computer generate a random number, and then we guess like between 1 and 100, and it'll prompt us higher or lower. That's the idea here. So let's actually start this up. We're just going to use our same little project here. We saw our cargo sort of configuration file. That was fun. That generates us a sort of main here, and we can run it. Okay, so let's actually get into some of the code here and then try to read through what's going on here. Let's see, can I close that? Yes, I can. Okay, so processing a guess here. Okay, fine. Well, this was so easy. We will just make a new project. That's fine. Let's do cargo new guessing game. Was that what it was? Yep. CD into guessing game and do this here. Okay. I'm liking that. That's cool. That's easy. Good job, cargo. Let's go ahead and open up Vim. And let's see. Got syntax highlighting. Great. Okay. Looks like we got a little our guessing game here. I think Rust also has this thing where it's like pretty tightly bound to like 80 or 99 characters. I think I heard on a recent podcast wide, so I'll try to adopt the style the best I can. And Rust folks can tell me if that's true or not as you're listening in here. Okay, here's our standard IO module here, and we could print some stuff out. That's cool. And I actually ignored this exclamation. We got to figure out what that's doing, but I'm sure it'll tell us. Okay. Okay, we're building the actual game here. So print line, guess the number, and we're gonna prompt the user. Please input your guess. Okay, and then we have a mutable variable. So I'm guessing. I mean, this is pretty obvious, and I think from Rust's push to doing everything at compile time, variables by default are immutable, but we have this mute keyword here. Starting to see that in languages just as a default. I think that's a good idea. Kind of dodging mutation. And again, part of this is you're helping the compiler figure out what it can do at compile time versus guessing. So that's an advantage in a language for sure. Okay, so from standard input, we're going to read a line. We're going to read that into, let's see, mute. So I guess we're modifying that. And let's sort of do this here. Dot expect. Oh, interesting. Failed to read line. Okay. Print line with the exclamation. You guessed. And then our guess here. Okay. So interesting. They've got this, what is this? They call this like the string interpolation or something where you can pass in your variables here. So that's pretty clean here. I think from PHP it also has like a similar curly braces type of thing here. This is nice here. This looks like we have this is like a way to chain together functions here. And I wonder if this has a universal function call syntax as well. That's nice. And then expect. Well, we've got to read about that here. If this is, if this fails, I guess what is happening, this is our, I don't know if this is an exception. That's probably not the right thing here in Rust, but let's go ahead and see here. Let's go cargo build, see if we made any mistakes. No mistakes. Let's go ahead and do a cargo run here. Please input your guess. 50. You guess 50. Let's go ahead and run this. Please input your guess. Let's say if I put in Mike, you guess Mike. Okay, so we got to cast these types of things eventually. Okay, yeah, this code contains a lot of information. So, okay, we bring in the IO library. That's from our standard library. They call it the prelude. Yeah, that's a nice way to, especially if you're learning this stuff, just to think about it like a book, right? This is the stuff before we tell our story, what actions we're actually going to do. So we have our prelude that allows us to use things like print line or any input-output functions here. Okay, and then we've got our main function. Again, they like the FN syntax here. We're not returning anything from main like you might do in other programming languages, but like most languages, that's our entry point for our function. Okay. Storing values with variables. Okay, so we are creating some storage here on the stack, I'm assuming, and setting up a variable. Okay, here's an example here. Okay, but the difference is, of course, with these two examples, okay, and how they write this here, we're binding the value 5 to apples, and yes, variables are immutable by default, meaning once we get the variable value, the value won't change. Okay, yep. Okay, variables and mutability comes up in chapter 3 some more here. Yeah, so if we're able to mutate something, or this is able to have a side effect and change here. I wonder if I can cast immutable things to be mutable in this language. I wonder how strong that is. Or if later on you just find out you need to change something and you just, during your declaration, put mutable or something. Okay, so let's see here. So the equal sign means we want to bind something. That's interesting. Yeah, because usually we use the syntax like for assignment or whatever here. So bind is already a new thing in the Rust language that, you know, I'm paying attention to now. And that's kind of more correct way to think about it, because it's a little bit weird when we have variables and we say like x equals 7 like mathematically, but saying we're binding a value, I guess that kind of fits here. I'd be really curious if for folks who are learning Rust as their first programming language, if you're watching this, what you think of that, if it makes sense, or if you care. I mean, if it's your first language. String new. Okay, so that's a function that returns a new instance of string. Okay. So I guess we were storing that just as a string value, and then we'll convert it later. Okay, and that's from the standard library, and these are UTF-8 encoded strings. Yeah, D does this. I think Go is doing that. That's sort of the standard, and that's the right choice, I think, for languages. Right, just make everything UTF-8. I have heard Rust has lots of different string classes for whatever you want. Okay, the colon syntax in the new indicates that new is an associated function of the string type. Okay, so that's sort of like a namespace or a scope or something. Let's see. Oh, it's telling me here. An associated function is a function that's implemented on a type. Okay, in this case, string. Ah, okay. So that was sort of like when we were learning Go, how we associated something. Let's see. Rust, I'm assuming, doesn't have... well, we'll have to see if it has like classes and that kind of stuff, or if this is just how we associate things with a type. So what types of operations or functions work with this thing? It's basically just a struct behind the scene, I'm sure. Okay, new function creates a new empty string. You'll find a new function of many types. It's a common name for a function that makes a new value of some kind. Okay, yeah, so we're just allocating space for a string, new type. Woo, yeah, that's right. All right, so receiving user input. Okay, we're doing this with standard IO. If we don't import the library here, let's see. At the beginning of the program, we could still use the function by writing the function. Oh, okay, so you could still write out all the standard library functions out, even if I don't have this. Assuming the compiler is just smart enough to bring stuff in. Okay. The readLine function, okay. Calls the readLine method on the standard input handle to get input from the user. And then we're also passing mute guess as the argument to readLine to tell what string to store the user input in. Okay. I guess this is kind of interesting that we have this here. Whenever I see ampersand, I think sort of reference or address in other languages, like in C++. So it's kind of interesting that at the function call here, the call site here, we're saying that we are going to mutate guess when we're passing in here. Okay. Okay, the string argument needs to be mutable so the method can change the string's content. That's let's read line here. And let's see, the ampersand indicates the argument is a reference, which gives you a way to let multiple parts of your code access one piece of data without needing to copy that data into memory multiple times. Yeah, because usually when you call a function in most languages, or many languages, I should say, that I'm aware of, right, when you pass a variable in, that creates a copy of that variable, right, and allocates it on the stack, right? Which could be expensive. So, okay, so references are a complex feature, and we'll learn about how Rust makes them safe here. Okay, cool. Okay, let's get to this .expect part, because that's kind of new. Handling potential failures with the result here. When we're working with this code, okay, so we could have written this. Okay, we could have written it as one line. Yeah, it's nice to break things up. Okay, but read line puts whatever the user enters in the string we pass to it, but it also has a return value. Result is an enumeration, often called an enum, which is a type that can be one of multiple possible states. We call each possible state a variant. Okay, so it looks like a lot of these functions, perhaps in Rust, return some. Well, to call it a tuple might not be the right thing here, but it's what does it say? We call each possible state a variant. Okay, so it returns one of multiple states, probably either an error state or like the actual value we want here. Okay. Okay, yeah, so it returns either okay or error. Okay means that, yeah, things were fine. Error means there was some bad thing. Okay. How do we make it do a bad thing? Let's see here. Let's try to run this. Empty. Okay, that doesn't do it here. If I put in like some illegal character, I don't know how to make this crash. Let's see, how did they do it? Errors variant, which should be handled. I guess we're not handling it though. Cargo build. Warning, unused result. What did they change here? I guess if they didn't put in the guess or something, I don't know. Rust warns that you haven't used the result value. Oh, I see. If I get rid of line 12, maybe. So let's save that. Cargo build here. Cargo run. Oh, I don't know. I'll have to take another look at that here later. The result must be used though. Okay, maybe my compiler is a little bit newer and smarter or something. Oh, I see. If I don't have .expect here, I see. Okay, here. And then I put a semicolon there. Let's see what happens here. Okay, I just want to see these error messages here. Unused result that must be used. Okay, note that this result must be an error variant, which should be handled. Okay. Oh, I guess you can turn off some of these probably if you know what you're doing, but not like me since I'm new right now. Okay, interesting. So I could at least store it. Oh yeah, this is like the Google thing, or Go, excuse me, where you just use like underscore to store it in a value to ignore it effectively. Okay. I wonder if that's a common like pattern, but it's probably better to have like a .expect on probably all these IO statements here. Okay, so I'll have to read a Rust best practices book, or just read the rest of this tutorial here. I'm sure I'll get to it. Okay, let's see. Let's see here. What are some other new things? Aside from the closing curly bracket, there's only one more line to discuss. Yeah, print line. Okay, so it prints out user input. Curly braces is the placeholder. You can think of it as little crab pincers that hold a value in place. I like it. Okay. So that's this line here. Printing out a value, the variable name can go inside the curly braces. Okay, we know that here. Same order. What about the exclamation mark here? Why is that there? The never value. Does that mean that we're just calling this function and never using the result? So does that mean I can do like read line and exclamation? Oops. What if I just start putting these here? Is that a way to get around that problem? No, that just caused an error here. Okay. Never mind. Okay, let's see. Let Interesting. Printing values. Okay, at least we know that's printing. Maybe I skipped that somewhere. Let's keep moving along here, though. Testing the first part. Okay, we've got our guess. Let's generate a random number here. Okay, we need the random package here. How do we do this? And add it here. Okay, so we can add it explicitly here. What if I want the latest package? Can I just do cargo add rand or something? Cargo add rand. Okay. And let's see, did that update our file? Our cargo file? Yes, it did. Okay, and I picked the right thing. Cool, and our documentation's up to date, so that's good here. Okay, cool. Yeah, we might see different version numbers, cargo build. Okay, kind of skipping through some of this stuff here. Just because we want to see some more of the language here. Okay, cool. We can run cargo update. We haven't done that yet. Did that update anything? Yeah, okay. Let's generate the random number. Let's come down here. And before we make our guess even, oops, there we are. Let our secret number, and it's going to be immutable. We're going to use from the rand package. Ooh, thread RNG. Okay, and then we're going to generate something in the range of 1 to equal 100. Okay, interesting. Seems reasonable to me. Cargo. I'm going to cheat too. Let's print out that random number. And your number is between the crab pincers here. We'll go ahead and put that in here. Because I just want to do cargo run and see if that rebuilds every time. Okay, downloaded all the crates the first time. Let's see, did I make a syntax error? I didn't add RNG. And it told me that here. Great job, great error messages. Run. Oh, capital RNG. Okay, great. Your number is 75. Okay, cool. I can just do cargo run. I don't have to build and run it every time. Okay, so cool. Okay, I'm going to skip some of this stuff here. Apparently, we can do some stuff with documenting or looking at some of the documents here. That's kind of cool. Cargo doc open, and then click rand in the sidebar. Hold on, we got to try that here. What is going on here? Now that's cool here. It generated all the documentation for my project, and I've got rand here, and it's pulling it in from like whatever the official library is or wherever this documentation is. That's pretty cool. That just works here. I like that. Cool. Yep. Cargo is a win, in my opinion. This tool here, that's very nice. Dub, similar in DLang, has some of these things you can do with generating documentation and stuff, but this is pretty nice. That's cool. Okay, let's go ahead and compare. Let's go ahead and try to win our game here. Match. Okay. Match. Guess. I'm going to compare to my secret number here. It's interesting here. Okay, cool. They're showing off. Does this have pattern matching in it? Cool. Well, I can see why people like Rust here, especially if you're coming from like a functional world. Ordering less. Okay, so in C++ you have stud less, stud greater, stud equals, and so on. But in Rust we have this here, too small. Okay. Oh, and we just put a comma here. Let's copy this a couple times. Ordering greater. Okay, so this is cool. This compare function must be just taking in two things, and then I guess it well, we'll have to read about this if this is either just a function that's taking in three things here. Oh, I gotta be careful here. So if my guess is less than the secret number, it's too small. Okay, too big. And then this is gonna be you win. Okay, you win with 2 exclamation points. Okay, so let's try to run this here. Oops. And I got to use the correct syntax. Let's get rid of that curly brace. Oop, what have I done here? Oh, I need to bring in another package here. Let's see how Rust did on giving me error messages, mismatched types. Consider importing one of these. Okay, it's giving me a bunch of these packages. This is the one that our little tutorial is telling us to do. Just gonna copy this in. I wonder if, and this is something I'd be curious with folks, you know, like Clang has fix-its where you can just click on these things and then it'll just bring it into your code. I wonder if it has that or if folks would want that information here. Let's see, what have I done here? Okay, I have our secret number. Okay. Oh, do I have to pass that in as mutable? Let's see. Match, our guess, compare. And then we have our curly braces, and we're looking at the different conditions here. Different orderings. And then I print the lines here. Oh, okay, so that's okay. Make that just a little bit bigger so you folks can see the source code here. What have I done here? Could not compile guessing game due to previous error. Oh, do I have to do like cargo update or something to bring it in? Cargo build? Nope. Okay, let's read the error message. Expecting ampersand string here. Okay, I wonder if I skipped something. Oh yeah, okay. Should just read the rest of the tutorial. So we are, oh, I see, yeah, these are strings, and we've got to figure out the ordering. Maybe that's the, yep, that's the issue here. If we read down here, string versus integer. Cool, okay. So we got a mismatch type. We've got to convert it or cast it somehow. Okay, so we've got to make our guess a U32 here. Okay. Oh, interesting here. So I've got my guess here that I'm mutating. And then I've got my guess here, which I'm converting to a, 32 thing. Okay, interesting. I guess I can reuse that variable or change it after I've wrote it in. Let's see, let guess, and it's going to be U32 equal. Guess that was a string. I'm trimming it, parsing it, which I'm assuming is going to read in all the characters, or maybe the first characters that are numbers. And then expect, please type a number. Okay, so that's if I do something illegal here. Maybe we can see that error code. I'll probably do something illegal here. Okay, let's try this here. Cargo build. Okay, so that's really interesting. I guess, are these considered like two different types here or something? I can use the same name. That's interesting. Yeah, doesn't the program already have guess? It does. Okay. Rust allows us to shadow the previous value of guess with a new one. Shadowing lets us reuse guess variable name rather than forcing us to create two unique variables. Okay, interesting. Some language folks like variable shadowing, some don't. So that's an interesting design decision right there. This use case probably makes sense where we have strings and then that we just want to cast it. Anytime you're casting it, right, you'd want to use the same thing rather than calling this guess underscore string or something, or int. That's fine. Okay, so let's see if we can run our game. I'm gonna cheat here. 41, we win. 68, it's too small. 94, too big. Okay, cool. So we match on all those conditions here. That's pretty clean though. I like this matching syntax. Very clean. Okay, and trim gets rid of white space. Okay, so we got all this stuff here. Okay, we can just have a loop here that runs forever. And then eventually we want to quit here. How do we quit? We'll finish this game off and then we'll just look at some features and try some stuff off with Rust. This has been pretty insightful though. Just going through like this guessing game tutorial. This is always like the first program I write in every language, so I'm glad that they used this as an example. So that's kind of cool. Oh yeah, let's get it to go in the air mode here. Like if I do something illegal, like type in Mike for my name here. Okay, cool. Thread main panicked. Okay. Please type a number. Okay, so it's giving us our error here with the rest of the message. About where we made that here. Okay, and I can turn on the backtrace here. Let's do that. Let's turn it on. It's just giving me the ecosystem here. Paste. Rust. Okay. So now if I do cargo run, Mike. I might have to here. Export this. I might have to reset my environment here, but okay, that was it. Cool. Okay, so it's gonna be the full thing here. I'd be curious how the debug environment is for Rust if it just runs with GDB. Because let's see, are we just getting? Let's see. Let's list out what's in our target here. Do I get a debug executable for my guessing game? I guess so. So if I just want to run this without cargo, I can just do that. Okay, cool. So can I use GDB? And then I can use the TUI mode, layout, source, layout. Here. Oh. TUI layout. Source. There we are. Start. Okay, so we're in main somewhere. Next. Okay, I guess I didn't export the debug symbols or something. But maybe there's a way to do that. Since Rust is pretty similar to C, I mean, maybe there's some extra stuff going on in the runtime that you have to figure out, but I imagine it should be able to just use GDB on it. Okay, you could just break out of the loop here. Okay, let's fix this program though. Let's give ourselves a full program. Loop. That's kind of neat. I mean, that's what I want here. I just want an infinite loop here. And then here, okay, let's write out our block of code. Let's do something like this. We print you in, and then we just break out of our loop here. Okay. And then let's do a cargo run. Man, how many times I can write cargon? Okay. What did I do? I missed a semicolon. Yeah. Okay, there we are. Number 74. Again, I'm cheating here, but too small. Oh, yeah, I gotta make sure we let's put all this in our loop here. I'll show you the full program at the end here, although you folks have already typed this out by now and are way ahead of me. Okay. Paste that in. All right. I think we only need to allocate this string one more time. Well, I wonder how big is this string that I'm allocating? What if I start putting in larger and smaller numbers? Let's see if that does the trick. Otherwise, I'm just going to do it every time in the loop. It kind of cheat. Okay, my number is 93. Gotta guess something huge here, too big. 5. Okay, yeah, now I'm getting like a crazy error of some sort here. No, I did type in a number here, but I guess if it's not reallocating that every time, that's going to cause a problem here. Okay, so let's just do that in our loop here so we can run our game. 66, 9,000. Yeah. Okay, that's fair enough. I'll have to think a little bit about that. My understanding with Rust is once you get it running and working, it's perfectly capable and performant and stuff. There's no garbage collector or anything, so I'm wondering if I'm just like leaking memory and someone's gonna be, some Rust person's gonna be screaming at me reasonably here in this loop here. Like, do I have to free my guess or okay, so we can handle the invalid input here. I mean, this is really nice here for the error handling. I actually really like this. On basically everything that we do here on the matches, we could just have an expect and then like an okay and an error. I think I need to go back in time here. I think this was something similar to like SML. Maybe that'll be one of the programming languages because I haven't touched that in like 10 plus years, where you can do this sort of similar, that's sort of like a similar pattern matching type of thing here, where you have like your error case and your okay case. That's pretty neat here. Okay, so here's their program. Let's show you mine here. I typed mostly the same thing out here, but there it is, just so you can see it all on one go. On mine that works, and then there's that probably works better with a little bit of extra error handling there. But pretty neat language overall. I mean, it's pretty clean here. Let's get into some of the other interesting stuff though, when it comes to Rust here. I mean, that's a nice exercise. Good job for writing that here. Let's get to the ownership thing here. Okay, so first and foremost, actually, let's start with variables, mutability. Things are immutable by default. Cargo is going to warn us on that. Let's see, you have consts. We have that shadowing that we could see there. So that's kind of neat here. It's got a bunch of built-in data types here. Ooh, again, I wonder what they're doing with 128 here. If that's just like a placeholder, if they simulate that with 264-bit types. Is that like a double floating point type or something? Oh no, these are all integer types here. Or I wonder if they're using some sort of like SIMD. Ah, and they've got this here. I saw Go that had this similar here, where it's like, hey, do you want the for your architecture, whatever an int is? I suspect these things are useful for interopt with like C code or something that's running on like an old 16-bit embedded device, and you just want to use like whatever that int type is. That's probably fine here. Yeah, that's what they're talking about here. Although they're just talking about 64 and 32-bit architectures, but maybe it works in other embedded devices. Okay, so some things here. I wonder how they handle integer overflow. They've got some stuff here where you can, I guess, handle the panic, or there's different wrapping modes. Oh, interesting. Wonder if that's what that unwrap thing was. I'll have to look at that. Character types. We saw that those were Unicodes. Okay, cool. Functions. Let's see what we could do here. I'm trying to wrap this under a hour as per usual. Again, I think some of you are curious about the ownership model, as am I, so we're going to try to learn it in like 10 minutes. Here we are. Okay, ownership's Rust's most unique feature. Deep implications for the rest of the language. Yeah, it gives us the memory safety guarantees without the need of a garbage collector. So I wonder actually when I'm allocating that new string here, if it's, is it proving something about my program that this is not going to leak or something and freeing it? I wonder. Let's see here. What is ownership? In ownership, again, for those of you who are watching my other stuff, right? This to me, whenever I think about this is like unique pointer. Like one thing is owned at one time in C++. But I suspect Rust pushes this forward. Okay, so all programs. Okay, so garbage collection, that's how D gets away with it. That's D language's default, although you can opt into manual memory management or reference counting or whatever strategy you want there. Rust uses the ownership system though, and that seems like that's it. Other than you can again mark unsafe code, I believe, and allocate your memory or whatever. Okay, none of the features of ownership will slow down your program. Okay, it does take some time to get used to. Okay, so here's an explanation of this stack in the heap. You can check out some of my videos on like C or C++ to learn about that. It's the same for all the languages, or in DLang. Okay, ownership rules. Let's take a look at the ownership rules. Each value in Rust has an owner. There can only be one owner at a time. Yeah, so everything's sort of like a unique owner. Okay. When the owner goes out of scope, the value will be dropped. Okay, fair enough. Yeah, that's easy. Variable scope here. Okay, we won't include all the... Oh, okay, these are just the examples here. Okay, scope is a range which the program for which it's valid. Okay, so, you know, typical scope rules here. So this is like some stack allocated thing, and then S doesn't own it anymore. That's fine. Okay, so when S comes in a scope, it's valid. When it's out of scope, it's not. Okay, that seems fine. String type. Okay, so this is what we want to use here. Okay, and it's more complex, so that's why they're going to use this as an example. We'll concatenate on parts of a string that relate to ownership. Okay. Interesting. Yeah, because I guess if we're concatenating a string, we're allocating some new space, and then we need an owner to manage that. So if I create some string here, it's managing its own heap, right? Behind the scenes, when you allocate a string, you don't know how large it's going to be, so usually you heap allocate it, right, as a data type. Or if you're doing this initial allocation, maybe it is, exactly 5 characters and maybe a null terminator behind the scenes or something. Now, depending on how you implement strings in a language, right, you might exactly know the length, and basically just have a pointer to this data. Then you don't need the null terminating character because you know exactly how long the string is. Okay, so we'll discuss more of the method syntax. Okay, let's take a look at here. So I've got this mutable string here, hello, and I'm going to push on it. So this is appending to the string world here. What's the difference here? Why can string be mutated but literals cannot? Well, the difference is how they work with memory. Okay. Yeah, I mean, literal strings, like here, right, without the mutation thing here, this is just baked into memory somewhere, right? At compile time, you have a string in your program at a certain memory address with hello there. This string's mutable, and I can change it. Okay. Okay, so this is getting like heap allocation and stuff here. Yeah, okay, and they do something here like an RAII thing. Okay, where they call a destructor or something. The drop function, Rust, will be familiar to you if you've used RAII. Okay, cool. So I wonder if that's how you drop ownership and then you can reassign it. Interesting. Okay, variables and data interacting with move. Okay, so okay, now we're getting into some interesting stuff here. I've got 2 variables here. Let x equal 5, and then y is going to equal to x here. But we can only have one owner here. Okay, so who owns this value that's been binded to? Okay, we can guess that. That's indeed what's happening. Okay, integers are known values, fixed size, perfect. Okay, with a string, okay, very similar way. That is, the second line makes a copy of S1 and binds it to S2. Okay, but that's not quite what happens. Okay, yeah, this is getting into new ownership stuff. I mean, this would be like what I would expect to happen then if everything's basically a unique pointer, like in C++. I would allocate this S1 here with hello, and then as soon as S2 is assigned to it, S2 now has hello and S1 has nothing in it. Let's see if that's the case here. Okay, so take a look at figure 4-1. See what's happening in string. A string is made up of 3 parts. Okay, yep, it's got the length and the capacity. Group of data is stored on the stack. Okay, these are just local variables or something. Length is how much memory in bytes. That makes sense. And when we assign S1, S2, the string data is copied. Meaning we copy the pointer to length and the capacity on the stack. We do not copy the data on the heap. Oh, interesting. Okay. Let's think about what's going on here. Let's keep going on here. Representation does not look like 4-3, which is this one. Okay. Okay, so I guess when we're assigning like this, both those strings are just pointing to the same block of memory here. We're just updating the pointer. Okay, interesting. Yep. That's what happens with in like D when you have a slice and you're looking at another string here, right? They share the same memory. You need to duplicate it. So we get this picture here where both the strings are pointing to the same thing. So if I modify this, which can I modify this? No, this is not mutable. Oh, they're just views into the same string here. Okay, that's efficient. That's good. Okay, interesting here. But to ensure memory safety, Rust considers S1 as no longer valid. Okay. Oh, interesting. Okay. Rust doesn't need to free anything when S1 goes out of scope. Interesting. So if we try to use that, let's see what the error message is. Let's try to use this here. Let's do a quick cargo here. We're running out of time, but we will do this little example here. Cargo, new ownership. And have a little look at this. Let's see our source here. let's do let s 1 equal, let's see, string new. Is that the syntax here? Always tough learning a new language here. Syntax, okay. Oh, string, oh, from, okay, so it's just from the literal. There we are. Oh, but my camera took me away for a second. Here, let me scroll up. There we are. From, hello. Let s2 equal s1. Okay, and then if I try to print this out here, okay, here's another nice, I actually like this type of output here. For the strings here, where I could just put the, like a format string like in C. This lets me do cool things, like if I want to store this string in a variable and then just pop that in here, and then just provide the variables. That's kind of neat here. Cargo run. Okay, so this is where we're getting a bunch of errors, but it's going to warn us here. Oh, it's going to give me a little tutorial in the error message on how the ownership system works. That's pretty cool. Help, if this is intentional, I'll prefix it with an underscore. Oh, interesting. Okay. Let's see. Okay, but I'm not using S2 at all, so it's going to complain about that. And here's the error message. Borrow of moved value S1. Okay. Yeah, so I guess Rust really leaned into like the unique sort of pointer thing, move semantics in C++, which is kind of interesting. C++ got, I think, move semantics in 11, version 11. So in 2011, so that must be where they got this, which is kind of neat. Or other languages. So borrow of moved value S1, and then I'm trying to use it. Now if I try to use S2 here, is it happy? Because that should be okay, right? That is fine. Okay, cool. But it is saying, yeah, if I have two pointers to the same piece of memory, you know, who's the owner? That could cause problems if one leaves scope, right? Like let's do something wild like this, right? A different scope for these variables here. And that seems to be the, you know, that's a major issue here. Yeah, that's a problem. If I use S2, that should still be, that's still okay. Yeah. But yeah, the point is that, you know, if I didn't have this here, well, as soon as S1 goes out of scope, if it had a destructor or something and these both pointed to the same heap, it would destroy S1's memory. And then if I used it later on, that would cause a problem here. So I wonder if I actually use this. Yeah, I mean, I think this program's going to totally break here. If I do something like this here, right? I should get tons of errors here because I would use this string S2. It would free itself, maybe free its memory that it points to, which would free S1, and then you try to use S1 later. So it prevents you from these like use after free errors, you know, which are common memory errors. Okay, cool. Okay, so it's got like sort of the same or similar as other languages handle this, where you could clone the memory or something. Let's see, is that it? Yeah. So I need to make sure that this has its own unique memory here. Yeah, this is great. This is pretty similar, actually. D language has its own ownership system with the @live attribute where you can catch these bugs. But you do sort of the same thing here, where you start off with something, some value, and if you want its own thing, you use .dupe in D, but here it's clone. Yeah, to make sure that everything only points to one thing at a time here. Okay, so I sort of get it. So I mean, it sounds like there's more use cases here, but you just have to think about it. Oh, this is cool. Yeah, it has like take ownership, which is basically like move. Stood move in C++ sort of does that, but it makes it an R value so that you can transfer an R value reference so you can transfer ownership. And that's what Rust is making you explicitly do. Okay, I kind of like this. You know, this is probably a little bit of an annoying thing to start doing in a programming language, right? Yeah, basically you're implementing all of like C++ or taking advantage of everything in modern C++ is move and unique pointer, except the language just forces you to do those things, which are probably the right things to do here. Okay. Now I'm assuming, of course, if I read more into this, I can do something with, yeah, like borrowing the values here. Let's see, and maybe like there must be a way to cheat as well and say like, hey, I don't care, I want 50 things to point to this, right? And that's where you have unsafe code. Let's see if there's a little like unsafe snippet here, which is like the anti-Rust thing to do here. But let's see here. Unsafe Rust, yeah. Okay, because yeah, sometimes you just need to work with memory or whatever. Okay, so you're creating like immutable raw pointers, doing stuff, calling an unsafe function. Okay, yeah, you just mark them as unsafe. Yep, that makes sense here. Let's just throw in something here. I just want to do like a concurrency thing. Let's just run some more code. I got like 2 minutes here. I try to keep these videos to about an hour, but I just want to show some more code here. Oops, let's do set paste. Here. Let's look at, because one of the big things with Rust is, right, if you have a lot of safe code, you have unique ownership of all your objects, and you're doing things, you know, such that you don't have two pieces of memory pointing to the same location. That makes concurrency, well, you can kind of prove that you don't have data races, right? I think message passing systems also have some of these guarantees themselves, which is how they work. Now I wonder if you could still get a deadlock or how strong Rust is. Maybe somebody can comment if it prevents or has a deadlock prevention tool to it. But this is kind of neat. I could spawn some threads. Let's see here. I've got to figure out that syntax. Oh, but my camera's really saying it's time to go. But it looks like I can launch a thread, have it sleep for a little bit here. Okay, it's just like I was gonna say if that's a Lambda function here, but it looks like it's just launching a thread here. Let's go ahead and just run this here. Cargo run. Okay, cool. So that's pretty simple here. You got your numbers from the main thread. This is just a regular loop here. We didn't look at loops here, but it looks like you have ranges here, range-based loops here. So that's pretty cool here. Okay, so pretty cool here. I mean, so what can I say about Rust here? You know, these first impressions never sort of do things how to say justice, right? You can spend years and years mastering a language, but as a first impression here, it's pretty clean here. It's trying to prevent a lot of errors related to memory, related to concurrency. It's got a lot of modern features in a language, as well as, you know, features that are nice and that have been around, things like the matching. Cargo, I'm a huge fan of. I like this. This solves a huge problem here. I already like it. It might be one of the best build systems that I've ever used. So I'm happy that I've seen this tool and how it works. And I would work with it some more. And yeah, it's not surprising to see that Rust is quite popular. I think the way that they're handling errors seems pretty clean. That's something I would want to play around with in a larger code base, you know, just to see how, you know, easy that is to manage here. But overall, this book's pretty nice here as well. Again, you can tell a lot of care has been put into it to put this together, kind of keep it up to date here. And it would be interesting to see some of the systems programming features, since I'm a systems programmer, you know, doing graphics and that kind of thing here. We didn't even get to like the closures and that kind of stuff here. So the language is certainly a little bit larger than some of the ones that we've looked at. Like Go, I felt like I went through the tour. V, which was really similar to Go, in the like hour. I feel like I saw pretty much all the features. Rust, I feel like you know, and I fumbled around a little bit with the guessing game example. I think that was a great example. But I feel like overall, I just didn't get to touch on a lot of the features here. Like, let's look at the collections here. Okay, it's got a vector, it's got a string, it's got a hash map. Great. You know, those are like the three data structures that I need to write a program, essentially. In an array, I need a map and strings. You know, and occasionally it looks like, you know, then I can implement a tree or something or a graph. I'm pretty good here. Automated testing here. I know I'm extending this one a little bit. Cool. It's got built-in testing here with Cargo. Again, any language needs that. Again, makes me like Cargo even more. So I like that here. An IO project. I like that there's little projects in this Rust book. Again, this documentation is really good here. Building a little command line program here. That's cool. Yeah, I can see how folks like this language here. Reference counting with smart pointers. Okay, so yeah, again, this is where you have to box and unbox your data. Oh, interesting. Okay. Okay, so it's got like some sort of smart pointer that's reference counted, so maybe you can have shared data in this way here. Yeah, and it's got the same issues that, smart pointer shared pointers in C++ have, right? If you have cycles. Okay, cool. So, I mean, I'll go ahead and just end it here. Let's go ahead and get back to the Rust page here. Hopefully folks enjoyed this tour. If there's stuff or crates that I must look at, I think it's a really nice language. I'll probably revisit it at some point. Again, I think it seems pretty learnable. It would be interesting to try this out in, well, it's got a lot of different targets here, like just to do some more projects in Rust. I think it would be interesting to see here. It's certainly got a lot of potential here as a language. I like a lot of the modern stuff. I like the ecosystem seems pretty clean. Yeah, it'd be interesting to do some like graphics programming and that kind of stuff, because I've seen some engines and stuff I think that are interesting. So hopefully you folks enjoyed this lesson on Rust first impressions. Again, seems like a neat tool here to work in. And let me know what other languages you're curious to see. I'm still thinking about it, although by the time you see this, I might have a video ready. And of course, if you are a Rust expert, let me know in the comments below if there are things that I definitely should show or that you'd like other Rust programmers to know about who are just getting started that are really important or fun projects. And I'll be really curious to hear your feedback on that. All right, folks, with that said, thanks as always for your time and attention, and I'll look forward to seeing you in the next video.